Hello, I am Riley Frank, and I would like to welcome the Advisory Board of Electrical and Computer Engineering. Today I'm going to talk to you about MATLAB and the reasons behind why MATLAB is a problem here at UMD. So first of all, for those of you that don't know, MATLAB is a programming language or programming platform that is designed for engineers, scientists, mathematicians, basically anyone who works in a STEM field. And it is used for a multitude of different reasons in engineering and other STEM fields in the real world. It can be used for things from graphing complicated or complex mathematical functions to creating 3D models or applications, help you create macros, or even just simply develop an algorithm through an iterative or recursive solution, just like any other programming language can. So what exactly is it that is wrong with MATLAB here at UMD? Well, the real problem stems from poor communication, poor technical communication. And by that, I am referring specifically to the communication about the importance of MATLAB. The importance of MATLAB is not emphasized enough by instructors and advisors here at UMD to early on engineering students in the engineering programs here at UMD. And this ultimately could lead, in some more severe cases, to students leaving the engineering majors for more favorable non-engineering ones. So, in a more detailed analysis, let's walk you through exactly what I'm talking about. It starts with, as I mentioned previously, advisors and professors, instructors alike, not expressing the importance of MATLAB enough. By not talking about MATLAB thoroughly enough in class, it ultimately leads to students considering that MATLAB isn't that important and ignoring it as a skill. At the same time, the engineering program is designed to start introducing MATLAB-based content and MATLAB-based assignments, and these two things correlate often to students struggling with MATLAB-based content. This MATLAB-based content could be anything from a small homework assignment to a major project, but it is fairly inconsistent. With those assignments, you often, if you do not do well, or if a student does not do well, will see a significant impact on your grade and a negative one. And this leads students to do one of two different things a majority of the time. Either they recover and learn the MATLAB skills, but always have a dislike of MATLAB, or at least almost always have a dislike of MATLAB, or the student is unable to recover from the lack of knowledge of MATLAB and ultimately makes a financial and educational decision to move to a non-engineering major to avoid the MATLAB-based content. In the more positive result, it's still not 100% guaranteed that the student will go on to have success in the real world. MATLAB is something that is used in the real world quite exclusively, and if they fail to learn everything they needed to learn in the engineering program due to a poor emphasis on importance, it could lead to problems later on in life. Now, what exactly are these problems that I claim at UMD based in? Well, they start by being based in a poll that was conducted a few months ago across several electrical engineering classes. And across all those classes, 28 total students responded. And of them, a surprising 61% of them felt that most classes and instructors assumed that they already knew MATLAB-based content, or they already had some basic foundation of MATLAB. Another 7% also found, or were also found, to have never used or been taught or been required to use MATLAB in any way, shape, or form. And this is also very troubling, as it shows that there is a lack of standardization of being taught the MATLAB skill or the MATLAB programming language as you go through the engineering program. And this ultimately could lead to some pretty severe issues, as later on in the engineering programs, you're often expected to have some basis in MATLAB. And alongside this poll, I also conducted an interview with a former TA of mine who worked with students on MATLAB-based assignments on a regular basis in the class that I had him as a TA for. And through this interview, I learned some more troubling news, which is that on any given MATLAB assignment, he noticed that about half, or sometimes even more than half, depending on the assignment, would ask at least one question about the assignment, and specifically about a part of the assignment that was MATLAB-based content, due to the fact that they didn't have a good basic foundation in MATLAB, and as a result didn't understand something in MATLAB that otherwise you might have or should have. So I also mentioned previously, along with my other claim, that MATLAB is also a very important skill for life, and not knowing it could really hurt an engineer down the road, or at least an engineering student down the road. So in that same interview with the TA that I mentioned on the previous slide, we also talked about his own professional experiences with MATLAB, and he mentioned to me that there are many government agencies and companies that use MATLAB exclusively. They will buy hundreds or sometimes thousands of licenses and have the intent of having basically every employee who needs to use some MATLAB-like program to just use MATLAB. Alongside that, it is also a very important programming language because it is so versatile in many different fields of engineering and STEM. Some of those things include telecommunications and satellite communications, also things like signal processing, stress strain analysis, thermal analysis, the list goes on and on. Point is, it's incredibly versatile, and knowing at least the basic foundation of MATLAB can help you in almost any field of engineering imaginable. It is also an incredibly useful tool simply for its convenience and its ability to show a visual for experimental results or data. And this might not seem like it's that important or that impressive, but being able to show a graphical representation of experimental results quite quickly and quite conveniently can be a very useful tool for an employee working for a company who might be trying to show this experimental data to someone who otherwise wouldn't understand it in a non-visual way. And finally, the last thing that I learned from the interview was that the toolboxes that are provided by MATLAB or available through MATLAB are incredibly unique and are utilized frequently by these companies and government agencies. And once again, for those of you that don't know, a toolbox in MATLAB is very similar to a library in some other languages. A toolbox often consists of a specific set of functions that may be quite situational and do rather complex computations or calculations, but ultimately will lead to much simpler code, which makes things much easier to read for the person who wrote it. Another aspect of MATLAB issues that has been delved into on a more national level is the fact that this actually takes place in more places than just UMD. And there are three main aspects that have been found to be very similar to UMD through research that I'm going to discuss with you. The first of those is the fact that there just aren't really enough exercises given in the UMD environment. Short, simple, easy to understand exercises, and ultimately these should lead to a much better foundation. Miguel Rodrigo, someone who works for the mechanical engineering department as a professor down in University of South Florida, mentioned this in his brief essay published by Carleton College. And he expressed this as one of the most important and uh, best decisions that he's ever made. Another man by the name of Craig Warren wrote a report or paper on some issues with MATLAB and some ways that he thought he could fix it. And of the issues he mentioned, there were two aspects that were really important to the UMD experience. The first is that, just like UMD, the general MATLAB setup for most universities is a little too broken up and often leads to students picking up very specific and complicated pieces of MATLAB, but never do they get a basic foundation like they should. Furthermore, blending or blended learning is incredibly important, and getting the balance between in-class traditional learning and the online interactive experience is incredibly important with MATLAB. If the balance is off, like the way it is right now at UMD, where there's a lot more online supposedly interactive rather than there is in-class traditional, it will ultimately lead to the same problem that we have now. Another big problem that ultimately causes struggles with students at UMD is the fact that incoming freshmen often struggle with their first year of college, specifically because as they come out of high school, they often apply strategies from high school and, due to their success in high school, assume that this will work when in reality it won't, due to the new style of learning they need to adapt for college. Because MATLAB is introduced your freshman year, most often when you're an engineering student at UMD, it's incredibly important that there is a proper balance and a proper amount of in-person instruction during the initial teachings of MATLAB and the initial introduction of MATLAB. So after all that, I think it's pretty clear that MATLAB does need to see a little bit of change. But what exactly is it that needs to change, or how can we change it? Well, there are essentially 5 things that I think could help based on research, and we should go through them. The first involves the simple point that instructors and advisors should just emphasize the importance of MATLAB more thoroughly. By doing this, it'll help students to realize that it's more important of a skill, and they will try more heavily to learn it on their own, and this could ultimately help relieve a lot of the problems that are experienced at UMD and take a more preventative measure. 2 and 3 are kind of a combination. 2 involves utilizing the MATLAB course at UMD and making it a mandatory requirement for all engineers. By doing this, you skip past the more optional, the engineering students take it into their own hands option, and putting it more in the hands of the university to teach the skill, so that way all engineering students leave the university with the proper skills that they need. And 3 is a more basic introduction to MATLAB needs to be put in every class, if not going with the MATLAB mandatory course. By doing this, you build a better foundation. That way, no student is really ever left behind when you first start out with a new course where you plan on using some MATLAB-based content. And this, in fact, this concept is discussed briefly in a report written by Brian McKenzie, written back in 2008 for the Oregon Institute of Technology, where he tries to fix similar MATLAB problems and talks about this being a potential solution to some of the MATLAB issues they were having then. The fourth is teaching MATLAB in a more traditional classroom setting more often. As I mentioned on the previous slide, due to the Learning Well project's paper that it was based off of, they talked about how some students struggle purely based on the fact that they're applying high school concepts to something that is no longer high school based and does not follow the same style of learning. And so by transitioning more slowly with MATLAB, you may catch more students paying more attention and allowing them to struggle a little less by showing more in-class examples and have more in-class experiences. And of course, the fifth is a more project-based class. So you would take a MATLAB course, maybe make it still mandatory, and have it run a little bit more like the C classes that we have now in the electrical and computer engineering department, where you have projects that get progressively more difficult. This is something that is proposed by Ella Ackerman in a paper that she published. Overall, I hope you found this presentation interesting, and I hope you take this issue seriously and consider it as something that you might want to change. Here are a few works cited if you would like to check up on these. Thank you.